Okay, so in these two problems, we're going to use our understanding of special triangles to find the areas of triangle ABC. And here in the first one, triangle ABC is right here, ABC. Here we have a 45-degree angle, so if we have a right triangle and we're given the right angle there, we know we have a 45, 45, 90, or special triangle here because, of course, the angles have to add up to 180. A great property of this triangle is that the two legs are equal. So this leg over here is also 5. Now we can use the Pythagorean theorem to find out that this is radical 50, right? Which of course equals 5 radical 2. Break that down. But we don't even need this hypotenuse necessarily because we're trying to find the area of this triangle. I'm going to use this leg as the height. So we have our height. We just need our base. So we need to know how long is AD. So we have the whole base here of A to C. And that's not so bad to do because here we can use our Pythagorean theorem. Again, we have a right angle. Right, this is a straight line. And we have a 90-degree angle over here. So the remaining degrees is 90 degrees. So using the Pythagorean theorem, we have 5 squared plus b squared, right, equals 13 squared. So we're trying to solve for here the missing piece. We'll call it b. And here, 13 squared is 169. 25 squared is 25 plus b squared. And we can solve for b squared by subtracting 25 from 169. And that, of course, gives us 144. That equals b squared. So b equals the square root of that. And b equals 12. Once we know that, we have our base, right, where b is 12, plus dc, which is 5, so it equals 12 plus 5, or 17. And our height is the other leg right here, which is equal to 5. So now we combine these two, and we get base times height divided by 2. Here it's 5 times 17, well it's 85, divided by 2 is 42.5, and that's the area of our triangle. Right, so we have that, and next we have a similar kind of scenario, but we're going to use different special triangles. Here we go with triangle ABC, and we're given this 30-degree mark here. This has to be 90 degrees. Again, we have a straight line, which is 180 degrees. If we already have 90, the other angle must also be 90. So if we have a 30, we have a 90, the last angle has to add to 180, so it's 60. Now using the special properties of a 30, 60, 90, we know the shorter leg is half the hypotenuse. It's 4. And this other leg right here is 4 radical 3. Right? You take the shorter leg times radical 3, that equals the longer leg. And you can calculate that with the Pythagorean theorem, right? 4 squared plus something is 8 squared, and solve for b squared, and then solve for b, and you'll get 4 radical 3. But I'll leave that to you. Here in our other triangle, we can use the Pythagorean theorem again, but really you don't need to, because if we have this, if they both share a leg, they share an angle, and they share their hypotenuse, and they're both right triangles, we could tell, oh, we're going to get the same exact thing. This is also 4 radical 3. Right? Think about it. They both have a common short leg, so the Pythagorean theorem would say 4 squared plus, in both cases, it was an unknown b squared, and in both cases that would equal 8 squared. So essentially when we solve this equation and it works out that b equals 4 radical 3, notice we're solving the same equation twice, so it should give the same answer, and it would. So in both cases these legs on the bottom are 4 radical 3. Add them up though to get the total base. It's 4 radical 3 plus 4 radical 3. That's equal to 8 radical 3. Right? Just like 4x plus 4x is 8x. Same idea. And this is our base. Now our height is 4, so we multiply the height, which is 4, times the base and divided by 2. That's the area of our triangle, so 8 radical 3 times 4 and divided by 2. Now we can think of this division by 2, just like before, as multiplying by a half. And that means that we can distribute that 1/2, or excuse me, associate that 1/2 with any piece or term that we want to. So I'm going to take the 8 and multiply that by a half. That gives me 4 radical 3 instead of 8 radical 3. We're multiplying that by 4. So our answer here should be 16 radical 3. right? And that's our answer. That's the area of this triangle. All right, hope that helped.